Hello my dear students, this is Reema. So today in this session we will be starting the exercise 5.1 and 5.2 of Euclid's Geometry chapter of class 9 CBSE Maths. So those who are watching my channel without subscribing, please do subscribe to my channel. Don't forget to click on the bell icon so that you'll get notified when I add a new video. So let's get started. The first question is, which of the following statements are true and which are false? Give reasons for your answers. First statement is, only one line can pass through a single point. So, through a single point, only one line can pass. Is it true or false? You know that that statement is false, because through one line, through one point, infinite line can pass, right? So the statement is false. And the second statement is, there are infinite number of lines which pass through two distinct points. Let's see two distinct points. First point is this and second point is this. Through two distinct points, how many lines can pass? Only one line can pass through two distinct points. Through one point, infinite number of lines can pass, right? But through two different points, only one line can pass. So this is also false. A terminated line can produce indefinitely on both the sides. According to the Euclid's postulate number 2, a terminated line can be produced infinitely. So a terminated line means a line segment can be produced infinitely on both sides. So that statement is again true. Our fourth statement is, if two circles are equal, then their radii are equal. So if two circles are equal, what will happen? Let's say this is my first circle with radii x and my second circle with radii x. If two circles are equal, I am taking this circle and placing on top of the circle. So again with radii x, this is my first circle and second circle. So my first circle coincides with the second circle. According to Euclid's axiom number 4, things that coincides with the same thing are equal to each other. So the radii will be equal. So this statement is again true. Statement number 5. In figure 5.9, if AB equal to PQ and PQ equal to XY, then AB is equal to XY. AB is equal to PQ, PQ is equal to XY, then AB is equal to XY. According to Euclid's axiom number 1, things which are equal to the same thing. Here AB is equal to PQ and PQ is equal to XY. Okay, then they are equal. So this is also true. Next we move on to question number 2. Give a definition for each of the following terms. Are there other terms that need to be defined first? What are they and how you might define them? So are there other terms that need to be defined first? So first here we see parallel lines, perpendicular lines, line segment, radius of circle and square. Yes, we need to define terms like lines, circle, points and all before defining these terms. Okay, so yes, this question is yes. And how we define parallel lines now? Parallel lines is what? This line L is parallel to this line M. So how we'll define this? Two lines L and M in a plane are said to be parallel if they have no common point, right? L and M is having no common point, then L is parallel to M. So these are parallel lines. Now what are perpendicular lines? How we define perpendicular lines? Two lines L and M lying on the same plane are perpendicular to each other if they form a 90 degree between them. Then how we write them? L is perpendicular to M. How will we define line segment? So what is a line segment? Line segment is a part of a line which has definite length and endpoints. So here AB is a line segment. So what is radius of a circle? The distance of a center of the circle to a point on the circle. So here in this circle P is a center and Q is a point on the circle, then PQ is radius. Now how will we define square? Square is a quadrilateral. Square is a quadrilateral where all four angles are 90 degree and all four sides are equal. Here PQRS is a square. Moving on to question number 3. Consider two postulates given below. Given any two distinct points A and B, there exists a third point C which is in between A and B. The second one is there exist at least 3 points that are not on the same line. So first one, it says that given two distinct point A and B. So two distinct point A and B, then there exists a third point which is in between A and B. There exists a third point which is in between A and B. So this is the first postulate. Now the second postulate, what it says, there exist at least 3 points that are not on the same line. So this is a line. There exist 3 points that are not on the same line. Okay, these are the two postulates. So now what is the question? Do these postulates contain any undefined terms? So yes, it contains undefined terms like points, line and all. Okay, are these postulates consistent? These two postulates deal with two different things, right? So they are consistent. Do they follow Euclid's postulates? They do not follow Euclid's postulate, but we have an axiom, right? Given 2 points, there is a unique line that passes through them. Okay, if we are given 2 different points, there is a unique line that passes through them. Okay, it follows an axiom. The fourth question is, if a point C lies between 2 points A and B such that AC is equal to BC, then prove that AC is equal to half AB. Explain by drawing the figure. So here a point AB. Okay, a point C lies on AB such that AC is equal to BC. Then prove AC is equal to half AB. So here this is our equation. So we add AC on both sides. AC plus AC is equal to BC plus AC. So AC plus AC is 2AC. What is BC plus AC? BC plus AC is AB. So what will be AC? AC is, we transpose to the other side. So half AB. Hence we proved that. Now we move on to question number 5. In question 4, point C is called the midpoint of a line segment AB. Prove that every line segment has only one midpoint. Okay, in question number 4. So we have seen that what AB had a midpoint C, and we have to prove it has only one midpoint. Let's say this AB has another midpoint. Okay, so now what is it? AC is, we have proved, right, in question number 4, AC is equal to half AB if C is the midpoint. So now two midpoint are there, so AC is equal to half AB, first one, and now what? AD. Okay, this is AC is a midpoint, and now when D is a midpoint, AD is also is equal to half AB, our second one. So now what? Subtracting 1 and 2, that is 1 minus 2. How much we'll get? AC minus AD is equal to half AB minus half AB, 0. AC minus AD is what? CD. CD is equal to 0. CD is equal to 0 means what? C and D coincides. Okay, C and D coincide. So a line segment is having only one midpoint. Moving on to question number 6. In figure 5.10, if AC is equal to BD, then prove that AB is equal to CD. So here it's given AC is equal to BD. AC is equal to BD. What is AC? AC is AB plus BC. So AB plus BC is equal to, what is BD? BD is BC plus CD. BC plus CD. Now what we will do? Subtract BC from both sides. Okay, if we subtract, we'll get AB plus BC minus BC is equal to BC plus CD minus BC. So if equals are subtracted from equals, remainders are equal, right? We have studied that. So then what is, then this will be equal, right? This will be equal. So AB plus BC minus BC is AB. AB will be equal to CD. So we have proved AB will be equal to CD. Number 7. Why is axiom 5 in the list of Euclid's axiom considered a universal truth? Not, the question is not about fifth postulate. It's about the axiom. Axiom 5 in the list of, okay. Why it is called the universal truth? Because the statement is true in all situations. That is why it is considered as universal truth. Now we move on to exercise 5.2. Question number 1. How would we rewrite Euclid's fifth postulate so that it will be easier to understand? So what is Euclid's fifth postulate? Euclid's fifth postulate states that if a straight line falling on two straight lines makes interior angles on the same side of it taken together less than two right angles, then the two straight lines, if produced infinitely, will meet on the side where the angles is less than two right angles. So that according to the fifth postulate, two lines and the line, okay, when the interior angles is, if angle 1 plus 2 is less than 180, then if produced infinitely, they will meet at a point P. Okay, this is the fifth postulate of Euclid. So can it be rewritten so that it is easier to understand? Yes, it can be written as what two intersecting lines cannot be parallel to each other. So see, two intersecting lines, you know that this will intersect, right? Intersect with this if you produce. So this will never be parallel. The distance between these lines are not constant. It can be written in this way also. This is question number 2. Does Euclid's fifth postulate imply the existence of parallel lines? Explain. Yes, the Euclid's fifth postulate imply the existence of parallel line because if a straight line, okay, so consider two parallel lines, okay, L, M, a straight line is falling on this parallel lines and forming an interior angle 1 and 2 and 3 and 4. We know that the interior angles 1 plus 2 will be equal to 180 degree in a parallel line. So interior angle from the other side is also 180 degree in case of parallel line. So if it is produced infinitely on this side, it will never meet, and on this side also it will never meet. So the lines M and L and M never meet, so they are parallel. So we have reached the end of this chapter, and if you have any doubt, please do comment in the comment section. Also, don't forget to subscribe and share my channel if you like my videos. I'll come back with another interesting videos in my next session. Thank you.